Hi guys, so in previous tutorial we talked about very basic introduction to Hugging Face transformers and how to set up Hugging Face in your system and how to start working with it. And we talked a little bit about how we can like import various different models and pipelines from Hugging Face, which are like pre-trained models, so we can like directly import them and use them. And we took a very basic example of sentiment analysis where we just imported the pipeline from the transformer library of the Hugging Face, and we just analyzed the sentence, and the task was simple. We has to just classify the sentence by either it was positive or negative. So it was the basic introduction part on the Hugging Face, like how we can use Hugging Face and how easy it is to import various pipelines in the Hugging Face. So there are multiple pipelines in the Hugging Face which we can use. For example, we can use multiple models in the Hugging Face which are open source available in the open source community. But in this video we are going to go a little bit in depth in the pipeline section of the Hugging Face, where we are going to talk about what is the pipeline in the Hugging Face and how we can use it, what are the various components in the pipeline and how we can modify them and how we can change it according to our use cases and all these things. So let's just start with this video. So for this video I am going to use Kaggle notebook to demonstrate various operations in the pipelines of the Hugging Face and how we can like use this pipeline, and from using and convert it and do the basic components. What are the basic components in this pipelines and what we need to do. So let's start with it. So the basic pipeline concept in the Hugging Face transformer is like it's like a processing pipeline. So it contains majorly three components, which is tokenization and the model part and the pre-processing part. So let's go to the slide here. So these are the basic components in the pipelines of the Hugging Face transformer. So in these components, like the first task is to tokenize our sequence and then feed this tokenized sequence to the model, and then the model will output some results and we do some pre-processing on these results and we'll get our final results, which will be the label, which is either positive or a negative for a sequence of word or sentences. So what does tokenizer do is actually tokenizers take a raw input or raw text or raw sequences, for example multiple sentences, a single sentence, or stuff like that, and then we feed this sequence of our inputs or raw text into the tokenizer, and it will spit out the input IDs. So input IDs are basically unique IDs for each token that is being tokenized by the tokenizer. So we will look at in little detail about this in just few minutes, and these input IDs then are fed to the model, and this model will give us some logics. So logics are basically the input for the softmax layer, which will be used for probability predictions, and then we will with the help of this probability prediction we will output some results. For example, if it is positive or negative, like how much probability it is if it is positive and how much probability of it being negative. So this is the basic components of the pipeline. So this is what the pipeline is going to be in the Hugging Face, and we are going to be modifying, or we are going to working with this various components to better suit the model in the Hugging Face, or better suit the transformer model to our use cases. So let's just start with the basic. So we will just, to start working with the pipeline, we just kind of import the pipeline from the transformer, and here we are using auto tokenizer. So what this tokenizer do is actually it tokenizes the input sentence or sequences that we provided. For example, the thing about the models in this transformers is that they do not accept raw text as an input. They accept tensors. So we will talk about tensors in a little bit. So before the tensor, we need input IDs. So input IDs are like unique IDs for the raw text that we provide. So to convert this raw text into this unique IDs, we need to use a tokenizer. So the tokenizers are just basic functions or function that we provide our sequence to, and it will spit out some input IDs, attention mask, and all these things. So basically what tokenizer do at first is actually convert these sentences. For example, let's say in this case this is our sentence, learning about tokenizers transformer pipeline is easy. So there are various ways to tokenize this sentence, to tokenize this sequence. For example, we can use white spaces in between the sentences to convert this into multiple words of tokens of words. For example, learning would be the one token, about would be the one token, tokenizer would be the one token, and just like that for the whole sentence or whole sequence. And there is another way which will be to using each character as a unique token. For example, L will be a unique token, E would be a unique token, and A would be a unique token. So there is this way, and there is a third way which is kind of like hybrid for this word tokenization or character tokenization, which is subword tokenization. In subword tokenization, what we do is, for example, let's open this. So this is like the basic example. So in word tokenization, we just tokenize or split the words using the white spaces and punctuations, and in character tokenization we just split the words using unique characters, and then use this each character as a token. In subword tokenization, what we do not break each up to each character, but what we do is actually we do not break the tokens for the most frequent words. For example, we do not break T, O and K here into each character, because token is kind of a word in itself, and if we separate it into multiple characters, it will lose its context. So what we do actually is break this thing into multiple words which are frequently occurring. For example, token and ization can be two things with two different contexts. So we kind of divide the tokens here. So that's the basic gist of subword tokenization, and you can like read more about it on the documentation part of the on the HuggingFace community or HuggingFace website, like how the subword tokenization work and why it is like very useful to tokenize the sequences using subword tokenization. And yeah, so this is what we do. We just tokenize the sentences, and after the tokenization into multiple words, we convert these tokens into input IDs. So these input IDs, as we have talked about, are the unique integers that represent the raw text. So this is it, and so this is all is fed into the model. So this is not directly fed into the model. We need to convert all this into tensors, and then this tensor will be fed into the models. So this is like that. And also one of the things that we need with this sequence tokens and input IDs is attention marks. So we kind of need all these three things, and then we convert these three things into tensors, and these tensors we will feed into the models, any NLP model. For example, BERT and this model that we are using. One thing to keep in mind is that each of these models have a very different process of accepting inputs, accepting tokens. So we have to keep that in mind. So for that use cases, we are kind of using auto tokenizer. So it will like give us a basic process what kind of tokens the model is going to accept. For example, we are using auto tokenize from pre-trained, and we are using this as a checkpoint, this model as a checkpoint. So what this will give us is the basic model how to convert our sentence into tokens. So it will be the most suitable for this model that we are using, because each model have different process to accept inputs or accept tokens or converting sequence into the token. So we have to like use different kind of tokenization technique, but auto tokenizers does it automatically for us. So we are going to use it, and with the help of we are going to use sequence classification model for this. And there are multiple models, like you can read about this on documentation of the HuggingFace. I will put a link into the description. And after that, we have like imported the model that we want to use. Like we want to use this SSC SST2 English model, which is a Distilbert base. So we are going to use this model, and we are going to use a tokenizer based on this model. So this is what this whole code is doing. So let's just run this code. And let's just run this code also. So this is going to download bunch of this is going to download this pre-trained pipeline or pre-trained model, which we have just described as the checkpoint, and it will download all the weight and biases of this model. And so in this part, let's just talk about let's just take a little bit overview of how this tokenizers actually work. So let's say we have the sequence, this is our sequence, and let's just tokenize this sequence, and it will give us word tokens, and we can convert this word tokens into input IDs using convert token to IDs method in the tokenizer. So let's just use it, and all these things, they are specific to this Distilbert model we are using, and each model have this different kind of tokenizer thing that needs to be done. Otherwise we will have to like look into the models, what kind of input it take, and then we can convert it into the input tokens. So here we are going to use this tokenizer, and we can just convert it into the input ID. So let's just run this, and let's just see what kind of result it gives. So for example, in this code, we have the sequence, this is a sequence, and we convert it to the word token, and so this will be the output of the word token, like learning about tokens, as we have talked about subword tokenization. For example, here it is tokenizing this tokenizer word into tokenizers and s. It is converting into the multiple tokens using subword tokenization, and then we use this tokens, these sequences, word tokens, and convert them into the input IDs. So these are the input IDs, which are unique integers that are generated with the help of this word tokens using tokenizer. So we can like actually decode these input IDs, and it will give us the original sequence that we have provided it. So yeah, this is the original sequence that we have provided to this tokenizer, and now we have word tokens, we have input IDs. So let's just convert it into tensors, so we can like feed this into the model. So what we are doing here is actually importing the torch library, and inside the torch library using the tensor method and converting these IDs that we have generated to convert these IDs into tensor. So we can feed this tensor into the models that we are using. So this is the model that we are using, and we can like feed this model this input IDs which are converted into tensor, and it should give us some output. It should give us some output. The outputs of this model is actually the logics. Logics are like probabilities, kind of like probabilities, where it gives us like what is the probability of being the label 1, what is the probability of being label 2, and all this thing. So let's just try to run this. So one thing that will happen is that it will not work. So let's just run this. So yeah, so this is the error, like the error is saying dimension is out of the range. So that's where we have to like be careful. For example, these models, they by default they accept multiple sentences as a sequence. For example, here we are providing a single sentence, and we are providing it as a sequence, but in sequence by default there are multiple sentences. So to get rid of this problem, what we can do is actually convert this into another high dimension. For example, here I've added another dimension to it. So now this way it will this way the model will think that the like this is a sequence of sentences. So like that's how we can like provide it. For example, if we do this, so here we are looking at here we have input IDs in this one dimension, and we have added another dimension into it, and now this is tensor with these 2 dimensions. So that's how we, and this is the input that we are going to provide to our model. So let's just run this. So yeah, so now the output is the logics. So as we have talked about earlier in this video, like this model we are using, it's going to output the logics. So these logics that we are going to post process and have our final results, which will be the labels, which is either positive or negative. So we have the logics as an output, which is a tensor, So this is like, yeah, look at this. So this is the output, like this is highly probabilistic, this is least probabilistic, and all this thing. And this is the basic pipeline of tokenization in the transformers library of the HuggingFace. So this is like the basic in-depth kind of thing where you can modify various aspects of this pipeline. But we can do another thing. For example, this tokenizer library that we are using, we don't have to do all this thing manually. We can just directly provide our sequence to this tokenizer and it will spit out all the required thing, which is word token input ID and the attention mask. So attention masks are kind of very important topic in transformers. So transformers are basically contains two parts. It contains encoder and a decoder and an attention layer. So attention layer are like very heart of this transformers. So what does attention layer do is actually it decides whether this word of it, this token is important and how much important it is to the whole sequence that we have provided. So this is very important. The attention layer is kind of the heart of the transformers, and the attention layer also require an attention mask. So attention masks are basically tensors with the same dimension as the input IDs, which contains the mask, which contains the basic values like 1 1 1 0 0 0. So 1 basically depicts that the attention layer has to attend this or has to pay attention to this input, and 0 means attention layer has to ignore this input or input ID. So this is what attention layer do, and this is like the very basic architectural kind of thing. And I think I'm going to be making a video about the basic architecture of transformer and NLP in general case, and what are the basic component of it, how decoders work, how encoders work, and how attention layer in the transformer work. So I'll be like making a video about this like basic architecture of the transformer. So where I will like discuss in detail how this attention layer work. I'll be not doing very much coding part there, but I'll be looking at the very architectural kind of thing, overview of kind of thing, like how the basic workflow or how the basic pipeline in the transformer, how basic input to output works in transformers. So I'll be making a video about that. So moving forward, we have got our tensor with higher dimension that we can feed to the input, feed to the model, and we have fed it to the model, and we have got our logics at output. So these logics, we have logics, but as I was talking about, we can just automatically like do this tokenization part, and we have not to do all this thing manually. We can use tokenizer. We can provide the sequence to this tokenizer like this, multiple sequences, multiple sentences to this tokenizer, and we just give the input, and there's a padding truncation in this part. This is like, so here we have provided the raw input to this tokenizer, and it will give us inputs that we can directly feed to the model. So let's just run what kind of output it given. So here we can see like it is giving us output at input ID tensor and an attention mask tensor. So these are the basic things that we need to feed into the models that we are going to use. For example, as I've talked about the attention mask contains this 1 or 0 vectors, kind of vectors, which corresponding to either ignore this input, either ignore, for example, 101 input, or just take this input or pay full attention to this input. So this is what attention masks are used for. And now we have got our input. We can just feed this input to feed this input. So I think there is some issue. Let's run this again, and let's just run this again. So okay, so here it is. We have feed this input to our model, and it will give us logics for both of these sentences. So this is like the tensors for the inputs that we have provided, and it gives us the outputs. So with the help of this logics, what this logic is very probability distribution for higher classes in the labels, higher classes. For example, we can actually directly extract these values and see. We can just do an argmax here and see if it's if the sentence is either positive or negative. But if we want to distribute this probability of our multiple classes, we have to do a softmax. So softmax, what softmax do is actually it will distribute this probability and give us the output distribute probability, which what it does, softmax does is actually it's just exponentiate the logits and normalize the results. So it will give us what is the probability. For example, there is a 0.9 probability of being it's positive and 0.1 probability of it's being negative. So this is what softmax is going to do. So we are just going to use functions of the PyTorch, softmax function of the PyTorch. So here we are just importing here we are just importing PyTorch and functions of the PyTorch, and we are using the softmax function in it. So we are just giving this logits as an input to this softmax, and we are just getting the prediction. So this is here is the prediction. So this is telling us that probability of being it. So this is positive and this is, I guess, negative. So this has given us the outputs, the prediction, and we can just do an argmax here and we can get the results, like if either the sentence is positive or the sentence is negative. So just do this, and when we do this, and it will give us like the sentence 1, the probability, the highest probability of this sentence being positive, and there's a highest probability of this sentence being negative. So this is the result that it's giving us. For example, 1, it depicts that the sentence is positive or it's of the class of label 1, and the second sentence or second sequence is of the class of label 0. So this is it, and so we can just kind of like pre-process this tensors and see if and just print out the positive and negative results. This is it. So this is the basic functioning, the basic working inside the pipeline of the HuggingFace transformer, and how we can use this pipeline, how we can use the multiple component of it, and yeah, so this is like the basic architecture of the transformers. So we have the model input, embeddings, we can convert into the embedding, which is tokenization and all this thing. We feed it to the layers, and it will just spit out some tokenized result, which is like associated kind of thing, which give us the how this unique token is associated with the entire sequence that has been provided, and then feed this to the hidden states, and it will give us the head, and it will give us the model output. So this is the basic working of transformers in the HuggingFace library and how we can use it. And here we can just simply use different kind of models. So all this thing was to just explain the working of the tokenization and all this thing. We can just simply so all this thing that it required is just simply load the model, tokenize the sequence, that input sequence, and just feed this input sequence, tokenized input sequence into the model, and we will have final output results. So this was the basics about the pipeline in the HuggingFace. In the next video we are going to talk about fine-tuning the models, the pre-trained models in the transformer library, and how we can provide our own data sets, how we can provide our own inputs and train the model on top of that, and get outputs on our very specific requirements on NLP. So yeah, this is it for the videos, and I think I'm going to make a very basic kind of architectural introduction to the transformers, how transformers work, how we can provide the input to these transformers, how the attention layer work, and how the decoders works, and all this thing. So yeah, I think I'm going to make a video about this. So thank you for watching this video. If you have any questions and any comments and anything, just say that in the comment section and I will look into it. And I think I am going to like put the link to this notebook into the comment section, so you can like check it. And yeah, this is it for this video. Thank you for watching the video, and if you like this video, and this is the stuff that you are learning, or this is the stuff for you, or you may be learning it in the future, and you are curious about machine learning and NLP and computer vision, so I'm going to be making a lot of videos on these topics also. So if this is for you, like, so give channel a subscribe, and yeah, thank you for watching this video.